For you, let's educate you, can we? Winds blowing over the Halsan volcano in South Korea's Jeju Island cause mesmerizing cloud patterns. They're called KarmanVortexStreets. They're fascinating, aren't they? We're in the lab now with our winter weather expert, Tom Niz, explaining how the KarmanVortexStreets happen. I love this.
Oh, I can't get enough. This is my eye candy, the satellite imagery. You can see these curls and swirls in the atmosphere here as these northerly winds come over the island, and as they come around the island, they form these vortices here. In fact, they're opposite vortices when they do that. It is fascinating. Give you about 5 seconds here just to look at that, everybody. It is an amazing,
I gotta say, Tom,
aspect.
I've never seen this before.
Yeah.
And I'm blown away by it.
And they happen when the winds are a perfect direction going around an object like this in the atmosphere. It happens on many islands around the globe. So this is the effect, and we're going to show this real quickly here.
All right.
To show how this is set up. And essentially, it's a repeating pattern of swirling vortices downstream of a blunt body. And what we have here is a cylinder. We bring the wind around the cylinder, and it creates alternating vortices here, one in one direction, one in the other. And when you get these alternating vortices, it sets up what's referred to as a linear oscillation around this island. Now, islands don't move, but if you have something like a power line, Mike, you can actually start to begin an oscillation like this.
All right, Tom, so you actually built a power line.
I did.
Come on over, folks.
Sparing no expense here.
So Tom's garage
Yes.
has some fun stuff in it. So tell us what you've built here, Tom, and what we're going to see.
All right, so the fan is going to simulate the wind, and this cylinder, which is a paper towel tube, is going to simulate a power line. Up north in particular, you can oftentimes hear the power line sing or make a sound when you get a certain wind. They start to vibrate. If the wind gets real strong, they literally can start to gallop. And if you get a lot of ice on them, they can build up and literally gallop to a point where they can snap. So we're going to simulate that in the atmosphere, and it occurs, it's another part of the Karman vortices. The wind comes around here and produces alternating vortices, one on one side, one on the other, and it eventually sets up the oscillation.
All right, so here we go, Tom. We're going to crank this bad boy up.
And we begin to see the shake, and within a little period of time, it sets up the linear oscillation, and you can see how this is jumping up and down. And look at that. That is going pretty strong right now. This is what will happen to power lines. Power companies have to prepare for this, and they build and plan in certain ways.
And again, wind speed is constant right now.
That's
correct. Wind speed is not increasing, but our oscillation is increasing.
And look where we're going. And this also can happen around smokestacks. And there we go. We've gotten it to a point where we've literally snapped it.
Wow.
There were some cooling towers in England several years ago that actually came down because of the oscillation that's set up around the towers. Engineers have to build and plan for this.
And a lot of times, you mentioned this, if we get some ice accretion on some of the power lines, this can really exacerbate the effect and break just like that.
And that's exactly what it'll do. So power companies do plan for this, and they engineer for this as well.
Watch for it. KarmanVortexStreets.
That's it, all done in your garage. Now I can take my speaker brackets back.
The good news is it won't be very expensive to replace this.
No, that is true. That is true.
Tom, great stuff. Thank you very much. Send it back to Justin.